Well, there are many famous Chinese dishes, many of which have been created by accident. Sometimes it's because the lack of something in the recipe, so the chef chooses a substitute or improvises based on available ingredients in the kitchen, and thus creating a new recipe like no others. This human intelligence is amazing, is it? We can optimize the combinations to the available ingredients while not deviating too much from the goal set at the beginning. The result is a dish that is unique and effective every time it is created. However, the long-standing industrial production always tend to obliterate the individuality of materials. For example, logs are often broken into pieces and made into standard plywood panels. Can we create a new era of design and construction that is write an algorithm for a computer, give it the ability to self-study the properties of a certain material, then we input a guiding form, give it some raw materials and let it generate a suitable design according to the existing material conditions? Well, we soon found the raw material. This is a grove in our campus that is pruned once a year in winter to ensure that these trees survive the winter. These Y-shaped branches are often treated as garbage because they are so small and oddly shaped. We want to use this unusable material to make a construction. First, we needed to obtain the geometric models of these branches. To do this, we built a scanning chamber, and the algorithm of scanning modeling is shown in the video. After getting the basic information of the tree branches, we have to teach the computer to analyze, filter, cut, and combine them, and finally let them form a stable arch. The first layer of screening. Its purpose is to select the branches that are suitable as the main load-bearing members. The second layer of screening. This goal is to make the construction fit our preset arch. The third screening. It aims to reduce the amount of cutting as the construction continues. Fourth screening. Completing the arch shape and making comprehensive adjustments. After the structural analysis, there are some weak joints, so we add an algorithm to use some remaining wood to support them. The final result is verified to be feasible in Grasshopper. The next step is the design of the joints. The joints need to be strong, easy to build, high in fault tolerance, and accessible in a short time. We tried cordwood joints, mortise and tenon joints, and steel bar joints, but none of these were feasible for us. Finally, we used the combination of T plus universal joints. T-joint is a common component in HVAC, and universal joint is a common component for vehicles. This combination was actually my freestyle, according to the situation at that time. It looks strange, but it works quite well. These joints allow us to align and adjust the branches on the site, and after that we can weld them in right place, which greatly reduced the difficulty of our construction. Because of the difficulty of positioning the branches, we did try to use a robotic arm to help us build. As the video shows, we were able to use the robotic arm to position the branches to the right place. But later, because we didn't have enough time to write the obstacle avoidance algorithm, we gave up this method. But we had another method of positioning these branches, that is, augmented reality. We designed a simple software that can display our 3D model in the right place to the real site, using cell phones or tablets. With the help of AR positioning from 3 directions, we can build this pavilion more accurately. In addition, we tried many kinds of foundations as shown on the screen. But finally, we used a metal gasket foundation. This foundation is simple to construct and can be completed in a short time. There are 5 steps in total. First, compacting the plain soil. Second, smashing in the steel bars and the metal gaskets. Third, burying the bolts in the branches. Fourth, welding the steel bars. And finally, the whole foundation. We also had an interesting little design for the site, a gravel path. This gave the Fauvism-like pavilion a warm human touch. But unfortunately, there were some problems during the construction. Due to the accumulation of tolerances, there was a misalignment when the pavilion was 70% completed, and the error was even as large as 1 meter. When everyone was disappointed, I immediately came up with a solution. Delete the unconnectable part from our design. And we were done. Well, that was just a joke. But hold on a second. It can also be a special opportunity because we were designing an intelligent algorithm that can fit our purpose. So we could input the existing bad situation into the algorithm and set the goal to connect the gaps between the tops with those remaining branches. And so it did. After some time of computing, we probably sat there and played a few games of poker. Okay, this guy is me. We finally got an adjusted solution from the computer and used some of the remaining branches from the filter. Soon, we successfully completed the entire pavilion. Well, this pavilion looks weird in form, let alone any function, but that doesn't prevent it from being one of my favorite projects. Since there are not many examples to refer to, the whole process is like walking in the dark. We explored many possibilities such as image scanning modeling, freestyle joints, robotic arms, AR software, and most importantly, we explored a series of intelligence imitating material-specific and self-adjusting methods in design and construction. And we built an entity. It's like a chef improvising a new dish based on available ingredients. It's fun, isn't it? Thank you.